things always have a habit of going wrong. I was working on a video, it was almost finished, and then one of the modules I was using blew up, and I don't have the parts to fix it. So this is a bit of a mad panic to try and get something ready to publish, because the video is supposed to be going out tomorrow. So here, I just grabbed some random thing off my pile of crap, and we'll use this. This is a USB charger, which I got from AliExpress. It is, I think, oh, I can't remember how much I paid for it. I purchased this months ago. At a similar time, I purchased another charger from the same seller, which was utter shit. It was a complete death trap. So, I don't know, maybe this one will be better, maybe it won't be. This one is interesting because, as you can see, it has USB-C ports on it, and it says, if we look at the end here, I don't know, we'll have to see, hopefully you can read it, but it says model LYK-885. Actually, I'm going to take this wrapping off because I can't read the text underneath it. It says model LYK-885, the input is 100-240 volt, 50-60 Hz, 0.5 amp. The output is 5 volt, 2.4 amp, and then it has another set of outputs, which is 5 volt, 3.5 amp, 9 volt, 2 amp, and 12 volt, 1.5 amp. The reason I didn't cover this before is because I did not have a very important bit of kit in order to test this. My USB meter is unfortunately it is a USB-A one, and it does not do USB-C. So I couldn't test the USB-C output on that, and now I have a USB power meter which is USB-C compatible. So we'll use that and see if this actually is capable of doing the higher output voltages. Spoiler alert, I don't think it is. I would be very surprised if it was. Feeling this, it feels very, very light, so I'm suspicious. One of the other interesting things this has built into it is here. This black window, it has a voltmeter / amp meter built into the charger. And I've seen that before on other ones, and they were completely fake. And when I was playing with this one, I've determined that in fact it's not fake. It does actually change values, although how accurate that is remains to be seen. So without further ado, I'm gonna get out my appropriate testing kit and let's have a look and see what happens with these. See, does it pass safety tests? Does it fail them? Is it standard? Is it not? And whether this thing is safe to use or whether it's going to burn your house down. So, this is the setup I have. I have the hoppy here, so you can see how much current is drawn from the mains, power factor, all that kind of thing. You can see the display on the meter or on the charger itself here. I have the USB meter and my dummy load connected to the USB-A port, and I will read off the values on the meter because I can't show you both. So you can compare, well, you can see the information about what power it draws off the mains, and you can compare the values here to the values I'm going to read off the screen. Right now, it's outputting 5.12 volt, and the screen says 5.1 volt, which is fairly accurate. And I'm going to start turning up the amount of power it's drawing. So currently it's drawing nothing. If we turn it up, that's drawing 100 milliamps at 5.12 volt. Let's see if it changes to current. Nope, it doesn't. I'll try turning this up to give, let's say, 500 milliamps. There we go, that's 500 milliamps. It's outputting 5.08 volt. It says 5.2 volts, so yeah, it's not very accurate. And 1.55 amps. Yeah, that's a mile off. So this thing is completely inaccurate. It's drawing 29 milliamps with a power factor of 0.5. That's fairly normal, power factor of 0.5. It's consuming 3.7 watts-ish, and it's outputting 2.7 watts. So 1 watt of heat loss in the thing. Again, that's not amazing efficiency, to be honest. We'll turn this up some more. We'll go to, say, 1 amp. It says 2 amps and 5.2 volts, so 5.1 volt is the actual output voltage, so again it's slightly off, and the current is a mile out. 2.1 amp, absolutely not. This, I think, says it's rated for 2.4 amps, so we'll keep going up more. Let's go up. Here we go, so that's 1.7 amp, 1.8 amp, 1.9 amp, and the voltage is plummeting. So its current voltage is 4.1 volt, it says 4.4 volt, it says 3 amp, and the actual current draw is 1.9 amp. If we take this, I'll do an efficiency calculation, I'll put it on the screen. It is currently drawing 11.1 watts and outputting 8.3 watts, which is not good. Maths in my head is not good. I'll put what the efficiency is in percentage on the screen, but this is not amazing. The power factor of like 0.6 is fairly standard for these USB supplies. Well, switch mode supplies in general, but yeah, still, that's... Oh, and also it failed to meet, it said 2.4 amp, I think. Yeah, it says 2.4 amp, and it can't supply more than 2 amp. Now, the other thing I wanted to do, we'll unplug this, is I have, here, this is my USB power meter I was talking about. This one is a USB-C power meter. It does not, unfortunately, tell us the current, it just tells us the power consumption in watts. So that should be at drawing about, it's drawing 7 watts currently. I don't think you'll be able to, if I turn these lights off, maybe you'll be able to see the numbers on the screen. Oh, there you go, I can see that better. So it's drawing 7, we'll turn that up more, 8, 9, 6, 4, 5. Not good, not good. So it's failing to supply more than, if we turn that, 6, 7 watts, 8 watts, 9 watts, 10 watts, and then it goes back down again. So 10 watts at 5 volts would be 2 amps, which again is far off what I said. I think it said 3 amps. This here, yeah, spouting out nonsense figures again. The other thing I wanted to do with this was test it and see if it can actually output the multiple voltages. So in order to do that, I'm going to grab the guts of the project that was not working, and part of that is a USB-C trigger module here, which I will plug into this, and it is drawing power. It is not drawing power. Okay. Yeah, and there should be a PD light that comes on here, and there is not. I'll show you actually, I have a proper USB-C charger somewhere. Yes, I have one here. This is a proper USB-C charger, which I use on the day-to-day basis, and you'll see when I plug this in, it comes on, oh no, you can't see, it comes on PD 4 watts, and when I plug in this charger module and we plug that in, Does it do anything? No. Yeah, so hopefully, yeah, so this does still work. 4 watts PD on. This charger, it would now seem, is dead. Okay. Is it actually outputting anything? Nope. Well, that's interesting. Okay. Unexpected discovery, but still discovery nonetheless. This thing is probably going to be pretty terrible judging by that then, because usually things do not fail within a matter of minutes of use. I was going to do a load test on this, but I don't think there's any point really, because, well, it's dead. So let's rip it apart then. Okay, I'll be back in a second to cut this thing open. So, as you can tell by the plaster on my hand, I was not unscathed in getting this apart. I required rather some brute force, you can see, to take a lump out of it in order to break the case open. So that's good to start with. It's at least not going to fall apart when you try and unplug it. And on first glance at the circuit board, I'll probably take some pictures and put them on the thing, on the screen. But at first glance, or maybe I'll just zoom in because actually this is quite big. Where's something I can point with? There, that'll do. So first glance, this is not terrible. We have a fusible resistor, so it should be reasonably safe from that point of view. There is, on the back of the board, a not enormous separation distance, but it's far from the worst I've seen. It's meh. It should be much bigger. It's maybe, well, it's about the width of my screwdriver, and this is a 3mm screwdriver, so about 3mm. But it's not disastrous. Well, it is disastrous, but it's not as bad as it could be. We have a full bridge rectifier, the control chip, and then these are some parts to do with the primary side. Transformer, snubber capacitor, primary smoothing capacitor, flyback, feedback capacitor on the auxiliary winding. This is the interference capacitor, which is not as bad. Well, it's not as bad as some that I've seen, but this is not the correct capacitor, so this is still dangerous. I'm going to do some high voltage tests on this, but I want to go through something else first. Secondary smoothing capacitor, and then we have these daughter boards. These are all just in parallel, as you can see, and the observant among you will have already noticed this here is the place where the chip that does the voltage communication should probably be, if I'm making an assumption there, but I'm guessing it'll be correct. The CC pins and, well, the other pins on the USB-C connectors, which are to do with the power delivery spec, which is what lets you pick the voltages, are not actually connected, and also there is no feedback from the secondary side to the primary side in order to vary the switching. So, yeah, this is fake, basically. The rating saying it, power delivery spec, is fake. This interesting module here, it has a somewhat strange way of going about things. It has the power pins, and then this is the current shunt pin, as best I can tell. I'm pretty sure that this big resistor here is the current shunt. And I'm not sure what this one is. It looks to be 22K, I think. From measuring it, I didn't have a magnifying glass to hand to read what it actually says. But I'm not sure why it has this additional resistor in series with the shunt. Anyway, I have also worked out what's wrong with this. The output... Actually, one moment, I'm going to grab a meter. Okay, meter acquired. Hopefully you can see that. But if I probe I'm going to put one probe on the negative and one on the positive of the USB port, and the output is shorted. My suspicion as to what's causing that is probably this chip. If I had to guess, it will be this chip, because we were measuring about 1.2 ohms, which would be a reasonable resistance for the secondary winding. So I think that this chip here, which will be a synchronous rectifier chip, is probably dead and failed short, because you can see if I measure across it, it's short. And what we're actually reading is the resistance of the secondary turning on the transformer. So, as a little bit of an experiment, this might go disastrously wrong, but as a little bit of an experiment, I'm going to take this chip off and see if the fault clears. And if it does clear, I'm going to put a diode in. I don't have another synchronous rectifier to put back on, but I do have a diode. I'll put a diode in, and we'll see if we can resurrect this power supply. And then once I've resurrected it, I'm going to break it again. So, one moment while I go and do that, and let's see what happens. One moment. So it would appear my suspicions were indeed correct, because now if I take this and I probe here, nothing. That small beep you heard was the capacitor charging. And if I probe the chip itself, which is out of frame, I'll move that there. If I probe the chip, we get 1 ohm. We get 1 ohm across it, sorry, not 0.1 ohm, 1 ohm. Which, basically, yeah, this synchronous rectifier chip is the culprit. I would guess, because of how short of a run span this had, my assumption would be that this, most likely, is a fake chip. And by fake chip, I basically mean a chip that they've either taken out of another product, so e-waste, or a chip that has failed quality control in the factory and they have basically pulled out of a dumpster and used. So that's why the chip failed so fast. That's my assumption. Anyway, I'm going to grab some diodes. Going to have to give me a second because I'm not actually sure where my correct diodes would be. And I'm going to put some diodes across this, and we'll see if I can resuscitate this and breathe some life back into it before I destroy it again. One moment. Okay, so I have fitted, if you can see on the edge here, there were pads for a normal diode, so I've just fitted one. I did look for my Schottky diodes, and I can't find any. The Schottky diode, it should be a Schottky diode in this, and probably I would guess 5 amp rated, maybe more. And I do not have a 5 amp rated Schottky diode. In fact, I do not have any Schottky diodes that I can find. So I've put a 1N4007 in, which is a standard diode. This all comes with the, well, as you can see by the fact that this is plugged in, this all comes with the caveat of absolutely do not attempt to replicate this. I am professional, I know what I'm doing, I'm taking safety precautions and stuff, so don't be stupid. And with that said, I'm going to now turn this on. I have the camera going because I am suspecting there may well be a big bang and a flash and some blown fuses when I do this. So, we'll see. 3, 2, 1. No bang. Okay. Oh, okay. So it's kind of working. I don't want to. I don't have any VD things to. Hold on, I'll tip it like this. See if I can show you. Can you see? I'm nervous to short things. 1 second. I'm going to go try and grab some VD rated tools I can touch this with while it's live. 1 second. So the lights are off so you can see better, and well, the VDE tools I ended up using were called isolating it, which is the official way of doing things. I stood it up on this clamp, and I'm going to turn it back on and you can see what happens. The output appears to be pulsing, which might be that module is cooked, or it might be that the driver chip is cooked. The best way for me to tell that is going to be to take that module out and just see what happens, because I don't trust to plug anything into this, just in case. Oh, I know what it might be. No, I doubt it. I was going to say it might be that the voltage is too low, but I don't want to plug anything into this because there is a distinct risk it might be going to blow it up, because I don't know what it's outputting. So I'm going to take that module out and we'll test that module on the bench power supply, and we will see where it goes from there. So again, 1 second while I do that, I'm going to turn this off again. The fact it's keeping going like this after I've turned it off makes me think it's probably a driver chip issue rather than that module, because that feels like a primary capacitor being discharged. Yeah, I think this might be that the driver chip has gone bad. Anyway, I'm going to take that module off and we'll see what happens. So, 1 moment while I go and do that, please. And, yeah, what am I saying? 1 moment. I'm getting confused. 1 moment. So, I have the module out. I've not tried it yet, so we're going to find out what happens together. It's connected to my bench power supply in the polarity marked on the board. That's not necessarily the correct polarity, but I'm going to assume it is, because sometimes the Chinese stuff has polarity backward for some reason, and I can't bother checking because this is not important. So I'm just going to assume that they are correct, because usually it is, apart from when it's not. Anyway, let's turn it on and we'll see what happens. Nothing. I'm guessing that's probably because I'm not making a good connection. 1 second. Oh! It's because I'm being an idiot and I set the... Oops, I set the wrong channel. There we go. Okay, no, it does work. 4.9 volts and 3.1 volt, 3.1 amps. No, I don't think so. But, yeah, 4.9 volts, that's not far off. Wrong channel. Let's try turning this down to 4 volts and see what it says. 1.5 volts. Okay, we'll try 3 volts. 2.9 volts, okay, so that's more accurate. We'll turn it down again. It says, I don't know if you can read it, but it says 2 volt. Yeah, 2 volt, which is what I've got it set to, so that's accurate. We'll try maybe turning it up to 6 volt. 6.1 volt, and it says like 5 amp, 6 amp. I don't want to overload this, but it's a reasonably accurate, well, I say reasonably accurate, it's not a terribly inaccurate voltmeter and a pretty crap amp meter. I'm not going to test the amp meter setting on it. It has a 0.1 ohm shunt, so I could if I want to, but yeah, this module is fine. So I'm assuming that probably means that the driver chip on this sorry, I'm out of frame. The driver chip on this is probably dead. With that being said, I'm now going to go and destroy it anyway by doing a bunch of high voltage tests on it and see if it explodes. So 1 moment while I go and get my high voltage kit, and we'll see what happens when I apply some spicy voltages to this. And I'll tear down the transformer as well, because this doesn't work anymore. So 1 moment. So I'm going to skip the stupid test with like 10,000 volts, because we all know everything's going to fail that, and honestly I can't be bothered messing with all the, getting out all the safety kit and stuff to do it properly, and isolation transformers, and my big 10,000 volt mega is broken at the moment, and the shitty 11,000 volt one I've got, as I said, would need isolation transformers and stuff that I can't be bothered getting out in order to not risk unaliving myself. Almost said a bad word then. So I have this set to 500 volts. You can't see that, but this mega is set to 500 volts. I've got it across from both output terminals to both input terminals. The clips are shorting them out. I'm going to turn it on and we'll see what happens. It's reading 10,000, well, yeah, it's reading 10,000, which is 10,000 million ohms. or 10,000 megohms, and we'll do it on 1000 volts and see what we get. We get 5,000, but because of the range of this meter, that's doubled. So 5,000 times 2 is 10,000, so 10,000 megohms again. Yeah, so this passed its isolation checks. That's not massively surprising because it does have a not completely crap looking capacitor in it, and I would expect the varnish on the wire in the transformer to sustain 1000 volts for a few seconds like that. As I said, I'm not going to bother with the like 10,000, 11,000 volt test I sometimes do, for reasons I already said. So let's get the transformer out of this and tear it down and have a look and see what the isolation is like. 1 second. Okay, so I have extracted the transformer from the board, and let's take it apart now. So first step to do is going to be to try and peel the tape off the bottom of this. There we go. What am I doing? I'm going to need my hot air gun again. 1 second. So, now core is out, I have the bobbin here. First impressions, doesn't look too terrible. Double or 2 wires on the secondary side, which is fairly standard for a higher power charger. See if we can peel the tape off. So this here, judging by the number of turns, I would guess is probably the auxiliary winding. See if I can cut that free. There we go. Where's the screwdriver? Here's one. Yeah, so that's probably the auxiliary. There's a small gap. I don't know if you can see it. You can probably see it shining. There's a small gap at the bottom between the auxiliary and the... Ooh. I think that might be the secondary underneath this. Yeah, you can see the secondary kind of poking through the wire. Oh, sorry, I'm out of frame again. Yeah, you can see the secondary kind of poking through the isolation there. If this is the secondary under here, then this transformer has failed. And it's poking out here into where the auxiliary winding was. Through that gap in the bottom, that's not acceptable. Yeah, no, that is the secondary. So this transformer has failed that. The isolation is not adequate between the primary and the secondary. Oops, cut the wrong end of that one. That's unfortunate. Let's see what's the isolation like. Underneath here I'm expecting will be the primary. And yeah, look, it's poking out there. I don't know if you can see that. But the wires on the primary are just sort of sitting on top of the bobbin rather than being recessed into it, which the secondary winding was sitting on top of. So the isolation in this transformer is very far below standard. I'm assuming this will be the primary, there's nothing else it could be. We'll, for completeness, take this off. It's different colour tape, which I've not seen before, but yeah, this is the primary. If we take the end, did I cut the wrong end again? Yes, it seems I did cut the wrong end again. Is there anything underneath this? No, there's not. Okay, well, that's that then. Let's do a quick sum of the whole thing. So, summary. Not good. Not good. So, fake ratings. The current was fake, the voltage ratings are fake. Basically every rating on the device was fake, except I was going to say except the input voltage, but probably no, that could be fake too. I didn't test it on a lower voltage. So that's fake. The chips are substandard or fake or something because they just randomly died when I went to test them. I'm not really sure what happened with that. They just died. So there's that. The isolation in the transformer was substandard. It was dangerous. The isolation distance on the board was dangerous. Yeah, there isn't really much good going for this. The voltmeter display thing was horrendously inaccurate. The safety capacitor's fake. The only really good thing I can say is it's got a fuse. Beyond that, there's not really anything I can say. So yeah, be careful what you buy off of AliExpress because you're gonna get crap like this. And hopefully you found this video interesting. If you did, like, subscribe, do the things, leave a comment below if you've got any thoughts, and I will see you in the next video, which hopefully will go a bit better than this when I actually finally get on to doing project work. So yeah, I'll see you then.